Day 505 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3508, implement router. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Design a data structure that can efficiently manage data packets in a network router. Each data packet consists of the following attributes. The source is a unique identifier for the machine that generates the packet. The destination is a unique identifier for the target machine, and the timestamp is the time at which the packet arrived at the router. Implement the router class. The router class initializes the router object with a fixed memory limit. So the memory limit is the maximum number of packets the router can store at any given time. If adding a new packet would exceed this limit, the oldest packet must be removed to free up space. The add packet function adds a packet with the given attributes to the router. A packet is considered a duplicate if another packet with the same source, destination, and timestamp already exists in the router. Return true if the packet is successfully added, i.e. it is not a duplicate, otherwise return false. The forward packet function forwards the next packet in FIFO first in, first out order. Remove the packet from storage. Return the packet as an array with the source, destination, and timestamp. If there are no packets to forward, return an empty array. The get count function returns the number of packets currently stored in the router, i.e. not forwarded yet, that have specified destination and have timestamps in the inclusive range of start time and end time. Note that queries for add packet will be made in increasing order of timestamp. All right, y'all, so that may seem a little bit confusing at first, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So first thing I'm going to do is I'm going to copy and paste this input and output over here so I can give y'all a better visual representation of what exactly is going on. Boom. So come right here. That's the input. We put the output right here. Boom. And then let me see this. So we also need a router array. So that's going to be the router. And then we can also go through the output. So we put an output array. At the end, this output array should look like this output array that they gave us in the example. So let's go through it and make sure that we understand what's going on. So the first thing we want to do, we want to initialize the router class. So that's what this is doing. So before we get started, let me just explain what these mean, right? So this array, what this array and this array mean, right? So each one of these index, say this is index 0, this corresponds to this index 0. Boom. This where we call add packet up here at index 1, this corresponds to this array down here at index 1. This add packet at index 2 corresponds to this array at index 2. This add packet at index 3 corresponds to this index 3, and so on and so on. It'll make more sense as we go through it, but I just wanted to explain that first before we get started. So the first thing we do is we're initializing the router class with a max limit of 3. So once again, it says the max limit or the memory limit is the maximum number of packets a router can store at any given time. So sorry, this is the memory limit and this is us initializing the class. So we can return null in our output because we're not returning anything. We're just initializing the class with a memory limit of 3. Boom. So we can get rid of this. Since we already called it and so we don't get confused, we're just going to remove it as we go. Then we're going to call this add packet function right here with this array right here, with this packet right here. So we are going to add this packet to the router, and we're going to return true because it says, where does it say add packet We return true if packet is successfully added, i.e. it is not a duplicate, otherwise we return false. So since this router is empty, this packet can't be a duplicate, so we can add this to the router, boom. Then we could return true because it was successfully added. Boom. So now we could get rid of this because we called it, and we could get rid of this because we called it. So now we're calling add packet again. So now we're calling add packet on this packet right here. So we could just add this packet. Let's add it to the router. Boom. There's no duplicate, so it's successfully added. We could put true. Then we could just get rid of this so we don't get confused because we already called it. Boom. Now we're calling add packet again on this packet right here. But if you look, it says that this time it's a duplicate, right? So it's not going to return true. It's going to return false because we have this packet already exists right here. So since we can't add it, it says return true if packet is successfully added, i.e. it is not a duplicate. So in this case, this is a duplicate of this, so we don't return true. When we call this add packet, we don't return true. Sorry, y'all, we return false because it's a duplicate and it was not added correct, or it wasn't added successfully. So that's why we return false. Boom. So we can get rid of that and return false. Boom. Next, we're calling add packet again, and this time we're adding this packet right here. This packet does not exist down here. So let's add it. Boom. Boom. So it's added and we can return true. Then after that, we can delete it because we already called this. Boom. Now we're adding a packet again. So now we're adding this packet. So we can add this packet. But remember, the memory limit is 3. Boom. Remember when we initialized it, it only had a memory limit of 3. And right now we already have 3 packets in the router, which means we have to remove one. So what we end up doing is we're going to remove this packet right here, first in, first out. So we remove that one. Boom. And then we can add this one. Boom. And this is our new router, right? And then we could return true as well because we were able to successfully add it. Boom. So now we can get rid of this and we can get rid of this. Now we're on forward packet. So let's see what forward packet means. Right here it says forward packet return to 590 and remove it from router. So forward packet says, where we at? Forward packet removes the packets from storage, or excuse me, forward packet, the next packet in FIFO order, first in, first out. So we remove the packets from storage and we return the packet as an array with the source, destination, and timestamp. So since it's first in, first out, so since this is the first in, it's first out, so we could get rid of this. Boom. But we're going to return the whole packet. So we're not going to just return true or false. We are returning that whole packet. We're removing it and returning it. So that's what forward packet does. So boom, we could get rid of forward packet because we did that. We removed it and we returned it. Now we're on add packet. So now we need to add packet 5 to 110. So we can add that. Boom. Let's come over here. Let's add it right here. And then we return true right here because we were successfully able to add it. Now finally, let's get rid of this first since we called it. Now finally, last but not least, we're calling the get count function. And so with the get count function, we return the number of packets currently stored in the router that have not been forwarded yet, that have the specified destination and have timestamps in the inclusive range of start time and end time. So this 5 is the destination, and this 100 is the start time. This 110 is the end time. Now, as you can see, not to get confused, in the router, the destination comes second. So this is the destination we're looking for. We have 2 packets with the destination we're looking for, right? We have this packet has a destination of 5 and this packet has a destination of 5, but we want the timestamp to be within this range. So right now, this timestamp is not within the range, but this timestamp is within the range. So there's only one packet that has the destination and the timestamp within the correct range. So we return 1. Boom. And that's the last function, right? So in the end, this should look like this, which I believe it does. And so let's just bring it down here, make sure it lines up. Sorry, y'all. But yeah, okay, yeah, it lines up. So that's how that question works, y'all. I hope that made sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Now, the first thing we're going to do is when we get into the solution is we are going to create our package struct. So we could come right here above the class. We're going to create a struct. We'll call it packet. We'll say colon. It's going to be hashable. Boom. Then we're going to open up the bracket. So we need the ID of the sender. So we're going to say let source colon. That's going to be an integer. We need the ID of the receiver. So we're going to say let destination colon. That's going to be an integer. Then we need the arrival time. So we're going to say let timestamp colon. That's going to be an integer as well. Now we need to provide a custom hash so the packet can be stored in a set. 2 packets are considered identical if all three fields match. So we're going to create a function. So we're going to say func hash, open up the parentheses. We're going to say into hasher colon. It's going to be in out, and we're going to then we're going to say hasher. Boom, just like this. Then we're going to come right here. We're going to open up the brackets. We're going to say hasher.combine, open up the parentheses, pass in source. Then we're going to come underneath that. We're going to say hasher.combine, open up the parentheses, pass in destination. Come underneath that. We're going to say hasher.combine, open up the parentheses, pass in timestamp. Boom. Now we need a function to convert a packet back into an array in the format of source, then destination, then timestamp. So we could come underneath this, create another function, call it deserialize, open up the parentheses, open up the parentheses, just put some parentheses like that. It's going to return, sorry y'all, it's going to return an array of integers. Come right here, we're going to open up the brackets, and we're going to return an array, open up the square brackets. We're going to say source, comma, destination, comma, timestamp, just like that. Boom. So now let's get into this router class. So first we need a variable, or we need a constant that will keep track of the maximum packets allowed in memory. So we come right here, we can say private let memory limit, we'll say colon, that's going to be an integer. Then we need to track all packets currently stored. So we're going to say private var packet storage colon, that's going to be a set, less than packet, greater than, and we'll initialize it with a blank array. Boom. Then we'll come underneath that. We need a FIFO queue of packets to forward in the arrival order. So we'll declare a variable called private var packet queue colon. We're going to say dq less than packet greater than, initialize it with a blank array. Then we're going to come right here. We need a for each destination, a DQ to DQ its packets sorted by timestamp. So we're going to declare private var destination colon, it's going to be an array of integers colon DQ less than packet greater than. Come outside of that, we're going to initialize that with a blank dictionary like that. Then we can initialize the router with the memory limit by just coming right here, and we can say self dot memory limit equals memory limit. Boom. Now before we get started in all of these functions, we need to create a helper function. So the helper function is just going to help remove the oldest packets until the router's total packet count is at or below the memory limit. And we're going to use forward packet to do that so that all the structures stay in sync. So we'll come right here, declare private func. We could call it trim. Put the parentheses and open up the brackets. We'll say guard packet q dot count is greater than memory limit, else we can open up the brackets and we could just return. Boom. Then we come underneath this, we'll say underscore equals forward packet and put the parentheses. Boom. Now it's time to get into our add packet function. So for this is going to attempt to add a new packet, and it's going to return false if the exact same source, destination, and timestamp packet already exists. Otherwise, it's going to insert it into the packet queue, the packet storage, and the destination. And then if adding exceeds the memory limit, it will automatically trim or forward the oldest packet. So we'll come right here, we'll say let packet equal packet, open up the parentheses, source, colon source, comma, destination, colon, destination, comma, timestamp, colon, timestamp. Boom. Then we'll come right here underneath this, we'll say guard exclamation point packet storage dot contains, open up the parentheses, packet, come outside of that, we'll say else, we'll open up the brackets and we will return false. Boom. Then we're going to come underneath this, we're going to say packet q dot append, open up the parentheses, packet, come underneath that, we'll say packet storage dot insert, open up the parentheses, packet, then we'll come underneath that and we'll say destinations, open up the square bracket, destination, comma, default, colon, blank array, come outside both square brackets, and we're going to say append, open up the parentheses, packet. Then we'll come underneath to enforce the memory limit by calling trim. Then we'll come underneath that and will return true. Boom. Next, we're going to get into this forward packet function. The forward package function, not that long. It's going to remove the oldest packet in the overall arrival order and return its source, destination, timestamp, or any array if none, or an empty array if none, sorry. So we come right here, we'll say guard let packet equal packet q dot pop first, put the parentheses, then we'll say else, open up the brackets, and we'll return a blank array. Boom. Then we'll come underneath that and we need to remove the duplicate set, or remove from the duplicate set. So we'll say packet storage dot remove, open up the parentheses, packet. Boom. Then we'll come underneath that and we'll remove from the destinations DQ by saying destinations square bracket packet dot destination. Come outside of that, say question mark dot pop first, put the parentheses, then we're going to say return packet dot deserialize, boom, and put the parentheses, just like that. Now we're going to get to our get count function. So we're not done yet, but we're getting there. And the get count function counts how many packets for a specific destination have a timestamp within the inclusive range, start time and end time. And we're going to use binary search to find the range inside the sorted DQ. So first thing we're going to do is we are going to come right here and we're going to say guard let q equal destination square bracket destination, come outside the square bracket, and we're going to say comma exclamation point q dot is empty, meaning it's not empty. That's what that exclamation point means. Else, open of the brackets, and we're going to say return 0. Then we need to find the first index with the timestamp that is greater than or equal to the start time. So we're going to come right here. We're going to declare a variable called left. Set that equal to 0. Then say comma. Then we're going to say set right equal to q dot count minus 1. Then we'll come underneath this, start our binary search loop, and say while left is less than right. We're going to open up the brackets. We're going to say let mid equal left plus, open up the parentheses, right minus left. Come outside of that, and we're going to divide that by 2. Come underneath this. We're going to say if q square bracket mid dot timestamp is less than start time, then we're going to open up the brackets. We're going to say left equals mid plus 1. Then we're going to come underneath this, and we're going to, on this else, this if, we're going to say else. We're going to open up the brackets, and we'll say right equals mid. Boom. And then if no packet is within range, we're going to return 0 by coming right here underneath the while loop. We're going to say guard q square bracket left, come outside the square bracket, dot timestamp is greater than or equal to start time, and 2 and signs, q square bracket left dot timestamp is less than or equal to end time. Else, we'll open up the brackets and return 0. Then we're going to come underneath this. We're going to say let left most equal left. Come underneath that. And we need to find the index with the timestamp less than or equal to end time. So we're going to say we're going to say left equals 0, right equals q dot count minus 1, and we're going to say while left is less than or equal to right. We're going to open up the brackets, and once again do our binary search. We're going to say let mid equal left plus, open up the parentheses, right minus left. Come outside the parentheses, divide that by 2. Then we'll come underneath that. We're going to say if q square bracket mid, come outside of that dot, timestamp is greater than end time. Then we're going to open up the brackets. We're going to say right equals mid minus 1. Come right here. We're going to say else. Open up the brackets. Left equals mid plus 1. Then we'll come right here and we're going to say return right minus left most plus 1. And that should be all she wrote, y'all. I know that was a lot of code. You made it through the video. Give yourself a pat on the back. We're not done yet. We got an error. Can I find destinations? I think they should just have a no S. Excuse me, y'all. So let's see. Let's keep the S. Maybe I need to put an S up here. Let's see if that does it. Okay, no, that wasn't it. That wasn't it. So let's come back down here. Let's see where we went wrong. Maybe should have an S. Hold on, what was that? That was this function, right? Hold on. Let me go ahead and go ahead and run this again. Cannot find destinations in scope. Oh, I know where we declared that. We declared that right here. So this should have an S. Now let's run it again. Let's see if that, and it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 130 milliseconds beats 75% of users. Not too bad, not too bad at all. Make sure you get one more look at the code. This is the top part. This is the next part. And this is the part underneath that. Then this is the part underneath that. And then this is the rest of the code, y'all. And yeah, y'all, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.